The world we live in is made of things. Billions and billions of different things like pickles and pianos and dump trucks and octopi. And even though these things seem totally different, they're all made of the same stuff, just combined in different ways. To give you an idea of how this combining works, let's take something apart. Let's start with this bowl of macaroni salad. If you were to reverse a recipe for macaroni salad, you'll see it's made by mixing together a bunch of ingredients, like macaroni, mayo, vinegar, vegetables, and mustard. This type of combining is called a mixture. When you make a mixture, you're combining two or more things together without actually changing the chemical identity of those things. Like mud, for example. The soil and water in mud haven't actually changed. They're still soil and water. You've just created a mixture of soil and water. Mud. It turns out that macaroni salad is actually a mixture of mixtures, because many of the ingredients, like mayo and mustard, are already mixtures themselves, which is nice for us because if we look closely, we'll see the three main types of mixtures that exist. The size of the particles in a mixture determines the type of mixture. On one end of the scale is a suspension, like our muddy water example. You get this if you take big chunks of something and mix it with something else, so those chunks are just floating around. Take runny mustard, for example. You'll see a bunch of little particles like mustard seeds, pepper, allspice, and minced shallots all floating around in a liquid, in this case, vinegar and water. This is called a suspension because you've got particles of one thing suspended in another. Now, on the other end of the spectrum is a solution. The particles in this mixture are so small, they are the actual molecules. A solution is sort of like a suspension of molecules, where one type of molecule is blended or dissolved with another. Vinegar is an example of a solution where the molecules of acetic acid are blended with molecules of water. The chemical properties of the molecules haven't changed, they're just evenly mixed together now. Salt water and carbonated soda are both examples of solutions where other molecules are dissolved in water. The last type of mixture is called a colloid, which is somewhere between a suspension and a solution. It's when you take two materials that don't dissolve and you make the particles so small that they can't separate. Mayo is what happens when you take oil and water, which don't mix, and you bind them together, usually with the help of another substance called an emulsifier. In the case of mayo, it's lecithin found in eggs. And now you're left with really small globs of oil hanging out with really small droplets of water. Whipped cream, hairspray, styrofoam, and Jell-O are all other examples of colloids. So, let's get back to macaroni salad. You've got colloids like mayo, suspensions like mustard, and solutions like vinegar. But you've also got celery, shallots, and all other vegetable chunks that are also part of the salad. These aren't mixtures really, but we can break them up. Just like a TV can be broken up into smaller and smaller complex component parts. In the case of vegetables, if you keep breaking things up, you'll eventually end with thousands of complex organic molecules. Things like ATP synthase, and RNA transcriptase, and water. So now, once we've unblended all the solutions, unmixed all the colloids, separated all the suspensions, and taken apart all of our vegetables, we've reached the end of what we can unmix physically. What we're left with is a whole bunch of molecules, and these molecules remain chemically the same, whether they are by themselves or thrown together in a salad. If you want to separate these guys even further, we need to unmix things chemically, which means we need to start breaking some bonds.